Hi everyone, my name is Ashran, and today I'm going to explain the Prairie Math League High Score Round 153, Question 4. So the numbers 1 to 9 are randomly placed into 9 squares of a 3-to-3 grid. Each squares get 1 numbers, and each of the numbers is used only once. What is the possibility that the sum of the numbers in each row and each column is odd? So first of all, here's the 9 numbers that we're gonna use. And so first we're going to calculate how many possibilities if you just like randomly put all 9 numbers into the grid. So if you study probability, so for example, we start with this square, we just like randomly choose 1 numbers out of the 9 numbers right here. So there's 9 possibilities. And because each numbers is only used once, after we choose, like, for example, one of the numbers, we only have 8 numbers left. So for the next squares, there's only 8 possibilities. So the final answer is going to be the factorial of 9. So this is the number of possible ways of putting the 9 numbers randomly into this grid. So then because they're asking for the probability of the sum of the number of each row and column is odd. So we need to calculate how many possibilities are there to like have a not odd sum. So we can see the numbers 1 through 9, they're either even or odd. We can see the number 2, 4, 6, 8 are odd. So there's four even numbers, and five odd numbers. And we can try by adding, for example, 3 even numbers. And we can try, for example, 0 as an even number. 3 zeros adding together still equals to a even number, so this don't work. And if we switch one of the even number into a odd numbers, so 2 even numbers and 1 odd numbers, and we just randomly choose a even number 0 and a odd number 1, you can see the total final sum is a odd number 1, so this works. And if we change another even number to odd number, so even plus 2 odd numbers, you can see 0, 1, 1, the final sum equals to 2, so this don't work. And finally, 3 odd numbers, which equals to 3 if we use 1 as a odd number. So the final 2 possibility of having a odd sum is if the 3 numbers here have 1 odd numbers or 3 odd numbers. So you can see we have 5 odd numbers right here. So how about we just like randomly put in 3 odd numbers here and see where should we place the other 2 odd numbers. So we just randomly, for example, put 1 right here, and we can find out that if, for example, we put a odd number around somewhere around these 2 squares, we can see that this row will have 2 odd numbers, which cannot work according to this, and this row have 2 odd numbers, which will not work again. So the odd number cannot end up here or here because it's going to be the same. So the only possibility is here. So if we move these 2 odd numbers to here or here, we have the same result, which ending up like with odd numbers for each row and column. And if we move this odd number and this odd number to here, forming a cross, or here, forming like a reflection of the original, this shape, it will work again. So we can find the result that we need 3 odd numbers together in a row and 3 odd numbers together in a column. So, so we need here, here, here. So the odd numbers need to end up together. So what are the possibility of these kind of numbers together? So we have 1, 2, 3, 4, 5 spots for odd number, which we have 5 odd numbers to place in. So again, probability, we have the base of 9 factorial, and so there are 5 spots for odd numbers. So the first spot, we can just randomly choose one among the 5 odd numbers. So there's 5 possibilities. And then this one, 4, 3, 2, 1. So it's a factorial of 5. Times, because we know that they need to stick together. So there's 9 possibilities because they need to stick together. And then because there's 4 space for the even numbers, so we still need to use the probability of like selecting one from the 4 even numbers. So there's 4 possibility for the first spot, so 4 times, there's 3 possibility for the second spot, so 4 times 3 times 2 times 1, so it's factorial of 4. And then we can try to simplify this. We can eliminate the 5 factorial in the 9 factorial, so we'll get 9 times 4 factorial over 9 times 8 times 7 times 6, because we got rid of the 5 times 4 times 3 times 2 in the 9 factorial. Then we can further simplify this. We get rid of the 9, and because 4 factorials equals to 4 times 3 times 2 times 1, which is which are 3, 4 times 3 times 2 times 1, and we can see the 8 right here. 8 equals to 2 times 4, so we only have 3 up top, and we can eliminate the 3 by getting rid of the 3 in the 6. So the 6 will have 2 left. So we will end up with 1 over 2 times 7, which is 14. So the final answer is 1 over 14, which is D.